You can't tell him or her. You got it?
Hello, Andrew.
What is the code word we're putting in the video? Chocolate brownie?
Yes.
Chocolate brownie. No, we're not. Chocolate brownie is a code word. If you send it to me in email, then you get a little dummy snack from me, okay? So, first person to send that to me, chocolate brownie.
Hey, dog.
They miss you, Andrew. Anna? I think we missed you. We'll take a poll and we'll let you know the results. Okay, here we go. So, this is review, so I would like to go through it fairly quickly, but I want to be at the right tempo. So, tell me if I need to slow down for something, but let's be on our way. Terminal points. Do you remember what pi over 6 is in radians? Or in degrees? 30 degrees. Good. And so, if we have a 30-degree angle, do you remember what this terminal point is right there? This is 1. The short side is always 1/2, and the longer side is root of 3 over 2. So this coordinate is root of 3 over 2 and positive 1/2. I look familiar? Pi over 4 is 45 degrees. And remember, the hypotenuse is always 1. We get the other side by dividing by the root of 2, so we have 1 over the root of 2. And when we simplify that, we get root of 2 over 2, root of 2 over 2. So therefore, the coordinate is root of 2 over 2, root of 2 over 2. Pi over 3 is how many degrees?
60.
60. And so if it's 60 degrees, we have another 30, 60, 90 triangle. Now this bottom part's going to be 1/2, and the upper part is going to be root of 3 over 2. So our terminal point here is 1/2 root of 3 over 2. Remember we used to take like time and do that in class, and now we kind of want it to be second nature, right? Pi over 2 is how many degrees? 90. I don't have to make a picture, do I? I could just say it crosses here at 0, 1. Yeah. So ideally what we want to be able to do is we want to be able to determine the terminal point given these different radians. You remember what 2 pi over 3 is in degrees? 120 degrees. Let's jump back here so we can remember how this works. We're not going to fill out the whole piece, but we are going to try to get some general patterns here. Remember what we called this thing?
Unit circle.
The unit circle. Yeah, circle of life. Very good. Yeah. So 30 degrees was pi over 6. 45 degrees was pi over 4. And 60 degrees was pi over 3. And 90 degrees was pi over 2. And Lainey was not with us last year. And so I'm going to direct my attention right to her as though she was not here, okay, because she wasn't. But the way that I try to make this as simple as I can be is if we have 120 degrees, 135, 150, and 180. Once we know these 5, these are then the key to figuring out the rest. Which one of these, 0, 30, 45, 60, or 90, divides into 120 evenly? 60 goes in how many times?
Twice.
So therefore we have the 2 pi over 3. So Brody didn't actually memorize that 2 pi over 3 is 120 degrees. Brody knows that pi over 3 is 60, and he just doubled it, right? What divides evenly into 135 up here? 45. We don't actually, take 45 times 3. We just know that there's 3 slices of pizza that fit in that piece, so it's 3 pi over 4. And what divides evenly into 150? 30 goes in how many times? So it's 5 pi over 6. Remember that, right? And if you were going to go ahead and fill out the terminal points, you can see that this is going to make, obviously, that 30, 60, 90. And so we have an x value of negative root of 3 over 2. and a y value of positive 1/2, remember which quadrant you're in. Remember constructing that piece? So let's do 2 on the other side, and then we will move from there. Brody said that 2 pi over 3, if you ever forget how to convert back and forth, you actually multiply by 180 and divide by pi. Which, by the way, Hannah and Hayden, I still haven't heard you guys' 100 days in office yet. Need to know your plan. Kings and queens need to have a plan. See the pi's cancel. 180 divided by 3 is my 60, and we double it to get 120. So the 120-degree angle, as we make that quick little sketch, it's going to leave how many degrees against the x-axis right here? 60 degrees against the x-axis. Remember that the longer side is the root of 3 over 2, and the shorter side is 1/2. So we have negative 1/2 and positive root of 3 over 2. That's the terminal point. I would say that that's probably one of the most important things that you could do within trigonometry and calculus is be able to find those terminal points. We all good with that? Do you need to try another one? Are we okay? We're good. Okay, so you could fill out the circle if you needed to. We don't really need to. But what about this? So you know what pi over 6 creates. Pi over 6 does create the root of 3 over 2 and 1/2. So the question is, what is the sign of pi over 6? Remember which value is sine, the x or the y value?
Y.
Sine is the y value, so sine is 1/2. Cosine is the root of 3 over 2. And how is it that we determine tangent? Sine divided by cosine, or y divided by x. And if you take 1/2 divided by the root of 3 over 2, we don't divide those fractions, we multiply by the reciprocal. I have 2 over the root of 3. Notice how they do reduce. I get 1 over the root of 3. Do I leave my answer like that? No, I have the root of 3 over 3. All of a sudden, it becomes pretty simple, right? Pi over 4, you know you're going to have the root of 2 over 2 and the root of 2 over 2, right? And so tangent is just going to be 1. In fact, if you consider the angle of 45 degrees, what would be the slope of a 45-degree angle? 1. And in fact, the tangent is the same thing as slope. Because again, tangent is y divided by x. See that relationship? Lots of beautiful things with trig as we work them out. So, you could figure out all these different pieces here, couldn't you?
Yeah.
I'd like to go one in particular, and that would be number 12. Number 12, I have 3 pi over 2. 3 pi over 2 is how many degrees?
270.
270 degrees. Good job. Man, you guys had a good teacher last year. You wait, NT. Gonna regrade your test.
Oh, so that means
We got 0, negative 1. What's interesting about this is the sine of 270 is then going to be negative 1. The cosine, 0, and the tangent, undefined. Because, again, see that it makes a vertical line, and the slope of a vertical line is undefined. I would say that this is probably the most important element that people need to know when it comes time to trigonometry, and they get confused with this. So let's try to work through this together, okay? If I have a 0-degree angle, what's the sine of 0?
1.
What's the y value?
0.
0.
Oh, yeah. Shoot.
What's the cosine of 0, Gilly?
1.
1. What's the sine of pi over 2? 1. What's the cosine of pi over 2? 0. What's the cosine of pi? Sine of pi?
0.
Sine of pi is 0. What's the cosine of pi? Negative 1. What is the sine of 3 pi over 2? Negative 1. And what's the cosine?
0.
0. And then 2 pi will be back to 0 and 1. Not too often you have to do the tangent and stuff like that, but the tangent of 0 is 0. Tangent of pi over 2 is undefined. And and so on and so forth that oscillates back and forth between those two pieces. I think knowing those sine and cosine values at those axes is really important. So you're probably about 50% of the way there from the trig review that we really need to be successful. If we flip it over, I don't think we need to do all those. I think they're good to go. But do you remember the basic graphs of sine and cosine? What shape does it make? And what is the period of sine and cosine? 2 pi, because that's one loop around the unit circle, right? So we mark off 2 pi, and we divide it into how many parts? Why 4 parts? Because there are how many quadrants in the unit circle? 4 opportunities for it to change sign. That's why we divide it into 4 parts.
Oh, I really forgot about how much I hated this.
This was the highest scoring test of the year for you guys. Where did it start? Max, min, or middle? And why does sine start the middle? Because the sine of 0 is 0. Does it head up or down? Up, and then our process takes us the rest of the way. We see the pattern, and we go through, and it's great. So, I want you guys, no, you guys aced the test. 50% of class aced the test. We do the next one. Cosine, same thing, 2 pi. And then after 2 pi, we, pi over 2, 3 pi over 2, negative 2 pi, negative pi, negative pi over 2, negative 3 pi over 2. Where did cosine start?
Up.
Why?
Because
Because the cosine of 0 is 1. And it heads down, and it cycles through the pattern. We can take what we thought was maybe a complicated graph. We actually make it quite simple. A lot of things in math are easier than they first look. So here's where I need you guys to meet me, okay? All right? And if you have a thought, if you could communicate with me, that would be great, because I don't read minds very well. When I ask you, what is the sine of 0, you have a couple things to think about. You could think about the unit circle, or you could just think about the graph. The sine of 0 is, and the cosine of 0 is. Like, you can just think about the picture, right? That's what's beautiful about the unit circle, is that the unit circle is the whole containment of the graph of sine and cosine right in front of us. So once you know one, you know the other, and they're both very well related. So, okay. We're not going to do all these, but we're going to just kind of talk about them. Do you remember what the 3 does?
Changes the period.
Close. It changes the, starts with an A, amplitude. It's stretched 3 units, so we go all the way up to 3 down to negative 3. In order to change the period, we take 2 pi and divide it by b. So the period in this case is just 1. Right?
Can you explain that one more time?
Yeah, the amplitude is equal to the absolute value of whatever A is. And so in this situation, the amplitude is equal to 3. But the way that we figure out the period is we take 2 pi and we divide it by the thing in front of x. So in this situation, the amplitude is going to be equal to what? 1. And the period is equal to 2 pi divided by, what do we divide it by?
Whatever's in front of that.
And what is in front of x here? 1/2. And 2 pi divided by 1/2 is going to give me 4 pi. Okay? I would say it's really more than you need to know for the graph of sine and cosine. Just knowing the basic shape and that it has 4 parts to it, that's really probably enough. You're not going to see a lot more than that. So, what about things like this? This you will know. You will never forget this. Sine squared of x plus cosine squared of x is equal to 1. Thank you. Never, ever forget that. 1 plus the tangent squared of x is equal to secant squared of x. I will hold you accountable to the first one on the test. I will hold you accountable to the second one on the test. And I will hold you accountable to the third one on the test. 1 plus the cotangent squared of theta is equal to, that's the only one we're missing, cosecant. For the double angles, I will only hold you accountable to the first one. And what that means is the sine of 2x is equal to 2 sine of x times the cosine of x. That formula is important. I'd show you where they all came from, but we can watch videos from last year and see. What about the cosine of 2x? What about that? What does that produce? Well, we have 3 different formulas it could produce, and you could choose the one that you want. I won't hold you accountable to any of these, but they do get used from time to time. Daughter just called me the other day and said, Dad, I used my cosine double angle formula. I said, good for you. So, she does say, and I will say, so as she's pursuing the whole engineering physics thing, she says that one thing that helps her be more successful, she says she knows her math really well. She says some of the people, they don't know the math quite as well. She said it really helps out. She remembers. And she had to look it up. She didn't like just remember it. Like she's like, oh, I think I should look that up. You know what I mean? So cosine double angle formula 1 would be the cosine squared of x minus the sine squared of x. Cosine of a double angle, another one would be 2 cosine squared of x minus 1. And another one would be 1 minus the 2 sine squared of x.
Yes, I do, because you plugged those in for.
Tell the person next to you, what of this do you remember? What do you not remember?
I do remember certain things.
I
I remember we were at sections.
I remember this.
And then I did okay on the test. I do remember that.
Something like you'd see something in that equation, like, oh yeah, that's kind of the same thing. Yeah, like simplify
Okay, or even in odd identities, these are pretty simple. Do you remember what happens if you have sine of a negative angle?
it. Turns to the other one.
Yeah.
It becomes negative sine of x. Do you remember what happens with cosine of a negative angle? It just goes away. If you want a description of why that is the way it is, I'll show you, but you kind of remember that, right? So that means that cosecant of a negative x does produce negative cosecant of x. And secant of negative x, because it is the reciprocal of cosine, the secant negative x just becomes secant of x. So it's cosine and secant that the negative disappears, whereas sine and cosecant, the negative stays. Same is true for tangent. Tangent of negative x is negative tangent of x. And cotangent of negative x is equal to negative cotangent of x. So let's just finish off by simplifying a few of these things. I have the expression secant times tangent times cosine. How would you simplify that? Go ahead.
Secant's 1 over cosine.
1 over cosine is secant times sine over cosine times cosine over 1. And if we see that, what do we notice happens?
Cancel out.
The cosines do cancel, leaving you with just the sine over cosine, right? And actually, from the beginning, I could have seen that secant and cosine are reciprocals, and therefore they will cancel, right? So this answer is just tangent of x. The next one, I have sine squared of x over 1, and I multiply it by a cosine over sine times 1 over sine. Cosecant is 1 over sine. What happens there?
Sine of x and the sine squared.
Yeah, the sine squared and the sine of x's, those do reduce, and I'm left with just cosine of x. What's 1 minus cosine squared?
Sine.
Yeah, so what Brody is saying right now is that if sine squared of x plus cosine squared of x is equal to 1, then we could come up with some new formulas, right? If we subtracted the cosine squared, we get sine squared of x is equal to 1 minus cosine squared. So when I say it's important to know that one, I also assume that you know that one. Agreed?
Yes.
And that you would know cosine squared of x is equal to 1 minus sine squared of x. So we need to know those. Suppose that you forget them, you can't use this on the test, but I have provided for you a number of sheets that could be helpful. Number one, the complete unit circle figured out, all of your even and odd identities and your Pythagorean theorems. I have all the formulas that you used last year in all of trigonometry. And I also have this piece right here. You see 1 minus sine squared is cosine squared, 1 minus cosine squared is sine squared with our Pythagorean stuff.
Okay, so was this at the end of the year last year?
It was in fourth quarter.
I feel like I actually remember this.
Yeah. So let's go ahead and simplify a few of these. 1 minus cosine squared, as you said, is sine squared over sine squared, which is going to give me 1. Yeah. So that type of expression, pretty simple. We'll go through the rest of them tomorrow, these last 5, then we'll get into our new unit. But that is the trig review. What I would encourage you to do is I would encourage you to keep this sheet of paper with the formulas so that you could reference them. But again, you don't get to use this for the test, but I would definitely let you know which formulas you would need to know for the test. Would you like your test back?
Yes.
Tell the person next to you, what do you think you scored out of 47?
Yeah, we got that last. Probably like 45. Give me 40. I know I threw last.
I don't know.
Nope. No, I
What did you guess? Okay. Never as good as your best test, never as bad as your worst. You're somewhere in between. Ooh. Nobody got the extra credit.
Shit. Actually, I do.
What'd you get?
I called it.
Oh, damn.
Zach, help
The
from
entire thing today. Oh, didn't even go through the
Probably. They get the ball out, yeah.
They are fast.
And see, that's a good sign.
Did you guys just have? I got more.
And put this there. They get the right answer.
There's really nothing to talk about from the test. You guys all did, pretty much the mistakes you made were different. There wasn't like one that was commonly run through.
Did they get 39?
We both
Yeah, so
Rudolph,
so that's the thing.
we have to check them, like you know that.
Right, so that's a whole piece of.
40 and a half.
Now, that doesn't mean you don't show the work, you do, but it would tell you it was 77.
That's what he got. What was this one?
Once again, the first 3 tests do help, how should we say it? Pad your grade, raise your grade.
When I started doing this, oh, you did it.
The next couple tests could be a little bit more challenging.
Yeah, I knew I messed that one up. Like as soon as I turned it in, like there's no way.
Brody, you were the only one.
Was I?
Yeah, he took that last problem, he just multiplied the whole freaking thing out. Dude, stop! Let me knock it off!
Yeah, Brody. Isn't that the thing that you said you'd like
Yeah.
do the spoon with?
Yeah, I did.
You show him
I
what
did.
you wrote on his?
Huh?
You wrote.
Yeah, I did. I was sitting there. I'm like, stop it, Brody! So I was going through all your tests. I think his was on the bottom. I'm like, yes, everybody did this like they were supposed to. And I get to Brody, so I'm like, Brody, dude, you're too good of a mathematician, not God. But I think he actually still got, or wait a minute, no, you did plug that, you got like 104 for the slope, didn't you?
107.
Yeah, 107.
Negative.
Slope was negative 74, so close.
I thought there was no way that was right.
Yeah,
When I got negative 74.
I thought it was wrong.
Yeah.
I was on that.
I would
I forgot to write it.
What I
Because
did.
I thought I was doing it the whole. Because I thought I like double checked it like how you showed me, and it said like 16, and I was like.
Oh, really?
I do, I mean, I have kept a number of those problems. Actually, this test I revised about 2 years ago, 3 years ago. I like it, but I've left that same problem there for quite some time. I do like it. I think it's a good exercise for us, so, yeah. I was able to take, if you guys notice, there's some of the things of our homework and our notes and the study guide was able to over-prepare you for the test. This next test is kind of harder to over-prepare you. You know, I mean, for example, like problem 2A and B, I mean, you're pretty confident with those finding the derivative, right? And then even the one on the other side, that was a little bit more involved, but you were pretty confident, weren't you? I could have asked harder ones, right? But it really wasn't necessary. The harder stuff on this test is necessary, the stuff that you're gonna see moving forward. So some of the algebra on this next test I can't get rid of. So. All right, good job. You guys had chocolate brownies, you had a trig review.